Hello guys, how are you today? So today I'll be explaining the IGCSE course question documents, only their required questions, which is question 3, 4, 5, 6, 16 and question 33. And by the way, if you cannot find the paper, just open the algebra, scroll all the way to page 60 and you will start by finding the first question, which is question 3. So let us start with question 3. They asked, consider the curve C with equation y is equal to x to the power of 3 plus 4x to the power of 2 plus 10. They need us to find the value of b if it is that it is a point on the tangent C at x is equal to minus 2. So we have the value of x being minus 2. Okay. What we need to find is the slope. Okay, so 10b is our answer, or what our answer is supposed to look like, and we need to find the value of b. As you can see in the hint, they said find the equation of the tangent, okay, and substitute x is equal to 10 to obtain the y coordinate. So before we start, let us find the equation of the tangent. Very simply, to find the equation of the tangent, first we need to find the slope. To find the slope, what we're going to do is we're going to take the original equation and we are going to take its derivative. If in the exam you are going to denote derivative formally, you denoted dy over dx. Okay? So derivative is dy over dx. Okay? In this case, the derivative of this answer is going to be 3x to the power of 2 plus 8x. Okay? This is our derivative. Now to find the slope, okay, what we're going to do is we're going to take that x is equal to minus 2. We are going to substitute it in this equation over here. So it becomes 3 minus 2 squared plus 8 times minus 2. So if we put it on the calculator, we get an answer of minus 4. So that means our slope is minus 4. And we know that the equation of any line, any tangent, is what? It is y is equal to ax plus b. And we found our slope to be minus 4. That means we are going to substitute a by minus 4. Now the next thing we're going to do is we need to find b, which is the y-intercept. Very simply, to find the value of b, what we are going to do is we're going to take x is equal to minus 2, okay, and we're going to substitute it in this equation to get the value of y. So, very simply, we're going to take x is equal to minus 2, we're going to substitute it in this equation, and we will get the value of y. So on the calculator, you will put minus 2 to the power of 3 plus 4 times minus 2 to the power of 2 plus 10. If you put it on the calculator, you will get an answer which is equal to 18. So you know that the x is minus 2 and the y that we just found it is 18. Now the next thing we're going to do is we are going to put it in this equation over here. So if you put it in that equation over here, it becomes what? It becomes 18. So substitute the y by y is equal to minus 4, and then substitute the x by x plus b. Okay, then solving it, you get 18 is equal to 8 plus b, and then you get the value of b to be 10. So now we have the value of b, which is our y-intercept, to be 10. So now the general equation looks like y is equal to minus 4x plus 10. Now, what they need from us is the value of b if it is 10b. So what they are telling us is that instead of x being minus 2, put x to be 10. What we're going to do is we're going to take x as 10. So it becomes y is equal to minus 4 times 10 plus 10. So after doing it, you are going to get minus 40 plus 10. So you will get that the value of y is equal to minus 30. Or in this case, the y is b, so you can write that b is equal to minus 30. And that is it for the first question, which is question number 3. We move on to question number 4. Question number 4 says, determine the nature of the stationary points of the curve C whose equation is y is equal to x to the power of 4 minus 6x to the power of 2 plus 2. When doing a stationary point, what we are supposed to do first of all is to find the derivative, okay? So let us find the derivative. Finding the derivative, you get 4x to the power of 3 minus 12x. Okay, so this is what it is. This is our derivative. Now what we're gonna do, because we are looking for the stationary points, whenever we are looking for the stationary points, we have to make this equation, which is the derivative, equal to 0, and we solve it. So on the calculator, for the people who don't have this function on the calculator, I will do it after, but for the people who have calculator, you go mode setup 5, but you do not put 3, you put 4. Why? Because we have it to the third power, and in the first slot you are gonna put it 4. The second slot you're gonna put it 0 because there's no number. The third slot you're gonna put it minus 12, and the fourth slot you're gonna put it 0 because there's no number. And you will get the roots, which are radical 3 and minus radical 3 and 0. Okay, for the people who do not have this option on their calculator, you can very simply so I'm not sure about the general formula, but what I did in this case was I made this bigger. So I said, okay, 4x to the power of 3. Then after to the power of 3, we have to the power of 2. So plus 0x to the power of 2 minus, 12x plus 0. Okay, I put it in this format. And then I used the quadratic formula. The quadratic formula is minus b plus minus radical b squared minus 4ac over 2a, or another term is minus b plus minus radical delta over 2a, or radical discriminant, however you guys know it. And then I just substituted. So I put minus 0 plus or minus radical 0 squared minus 4 times 12 over 2 times 4, and I got plus or minus radical 3. Okay, now this is one way to do it. Another way to do it is to take x as a common. So now you have x here, and you are left with 4x squared minus 12. And then you apply again the quadratic formula, but here it will become 4x squared plus 0x minus 12, and then you will get the same thing. And don't forget, because you made both of them equal to 0, you also have that x is equal to 0. So that means you have 3 roots in this case. So the 3 roots are going to be 0, and then plus radical 3 and minus radical 3. Okay, so now we draw the table of variation. Very simply, to draw the table of variation, we will draw something like this. Let me draw it a bit better. Okay, so here we have the smallest root, which is minus radical 3. Here we have the middle root, which is 0. And here we have the biggest root, which is radical 3. On top, it's gonna be x. Here, it is gonna be known as y prime, or the derivative, or the direction of the derivative. Remember, again, the derivative is 4x to the power of 3 minus 12x, okay? And then, in the last one, we are gonna put y. Okay, let me just fix this a little bit. I will fix it a bit so that it will look a bit nicer. So x, here we have minus radical 3, 0, radical 3, y prime, and then y. And always remember, our derivative is 4x to the power of 3 minus 12x. Okay, so what we're gonna do is we're gonna choose a number that is less than minus radical 3. So an example would be minus radical 4. So let's say you chose minus radical 4. Okay, if you are gonna substitute it in the derivative, what are you gonna get? If you substitute minus radical 4 in the derivative, by the way, minus radical 4 is minus 2, so you can do 4 times minus 2 to the power of 3 minus 12 minus 2, you will get a negative number. So over here, this is negative and it is going down. Now, if you choose a number greater than minus radical 3, so for example, minus radical 2, and you put it instead of x, you would get a positive number. You would get 4 radical 2, which is a positive number, so it is going up. Okay, if you chose a number that is greater than 0 but still is less than radical 3, for example, you chose radical 2. Let us see what would happen if you chose radical 2. You would get a negative number. You would get minus 4 radical 2, so it's going down. And then finally, if you chose a number greater than radical 3, so for example, radical 4, which is 2, let us see what would happen. You would get a positive number, you would get 8, so it is going up. Now they said determine the nature of the stationary points. Very simply, over here it's very obvious that this is a local minimum. Here this is a local maximum, and here this is also a local minimum. When do we know if it is a saddle point? A saddle point is if you have 2 increasing or 2 decreasing right after each other. Okay, and this is pretty much it for this question over here. Now, some extra things if you want to add, you could add the y. So how do you find the y? You're going to take the original equation and you're going to substitute these in the original equation to get the y. So the y for each one, for minus radical 3, its y is minus 7. For 0, its y is 2. And for radical 3, its y is also minus 7. So this is just extra information if you want to add. But in general, this is how we use the table of variation. So now we move on to the next question, which is question number 5. They said, the distance time graph below shows the journey of a train. They want us to find the average speed of the train in kilometers per hour. Pay attention to this unit, kilometers per hour, between 8 o'clock and 8:30 o'clock. Now, this is a distance time graph. Okay, so what do we know about the distance time graph? We know that the slope of the distance time graph is the average speed. So if they need the average speed from 8 o'clock to 8:30, we are going to treat it like a slope. So we're going to find the value of the slope by doing y minus y over x minus x. So pay attention, again, they need it in kilometers per hour. So you're going to take the first distance, which is 60, minus the second distance, which is 0, over the difference in timing, which is 30 minutes. But we cannot take minutes, we need it in hours. So we're going to divide it by 60 minutes to get 0.5 hours. So you are going to get 60 over 0.5 to get 120 kilometers per hour. So for part A, the answer is 120 kilometers per hour. For part B, they need us to find the average speed of the train in kilometers per hour, of course, but for the whole journey. So to find the average speed for the whole journey, what we're going to do is you're going to take the last point, okay, and the initial point. So what you're going to do in this case is you're going to take the difference in distance, which is 240 minus 0, which is 240, and the difference in time, which is what? It is 2 hours and 5 minutes. So 2 hours, we will keep it as hours, but 5 minutes, we need to change it into seconds, so into hours. So to the 2 hours, we are going to add 5 minutes over 60 minutes. So it's going to be 240 over 2 plus 5 over 60. So if you put it on the calculator, 240 over 2 plus 5 over 60, you are going to get an answer which is 115.2 kilometers per hour. So for the whole journey, the average speed of the train was 115.2 kilometers per hour. We move on to question number 6. We have a train started from rest at 7 o'clock. The train accelerated for 10 minutes to reach a speed of v kilometers per hour. The train maintained this speed for 30 minutes, then decelerated for 10 minutes to reach a speed of 0 kilometers per hour. The distance traveled during the entire 50-minute period is 90 kilometers. This is very important. The speed time graph below displays the trip graphically. They need us to find the value of v. Okay, value of v is the highest speed. Now, when dealing with a speed time graph, what we need to know is that the area of the shape of the graph is equal to what? To the distance traveled. So the distance in this case is 90 kilometers. It's equal to the area of the shape of a graph, which is a trapezoid. So the area of any trapezoid, it is height times base 1 into base 2, or like height times base 1 plus base 2, not base 1 again, base 2 over 2. So that means 90 is equal to the height that we need to find v times base 1. Base 1 is 30 minutes, which is half an hour, so times 0.5 plus base 2, which is 50 minutes. 50 minutes, let me check how much it is. It is a continuous decimal, so you're just gonna add 50 over 60, okay, over 2. Okay, so you multiply it by 2, you get 2 times 90, which is 180. So 180 is equal to the velocity times 0.5 plus 50 over 60. Then you can get that velocity v is equal to 180 divided by 0.5 plus 50 over 60. So if you put it on your calculator, 180 divided by 0.5 plus 50 over 60, you are going to get that the value of v is equal to 135 kilometers per hour. We move on to part B, which is... Now for part B, they asked to compute the average acceleration of the train in meters per second squared during the first 10 minutes. So we have that it is 135 kilometers per hour, and that the difference in time is 10 minutes. Now pay attention, they asked it for us in meters per second, so we're going to change each one, the 10 minutes by itself and the 135 kilometers per hour by itself. So 135 kilometers per hour, we need to change it into meters per second. Okay, so to change from kilometers into meters, we are gonna multiply it by 1,000 meters. Okay, and in the bottom, we are gonna have 1 kilometer, because per every 1,000 meters, we have 1 kilometer. All right, and then, or like every kilometer is equal to 1,000 meters. And then to change from hour into seconds, we know that 1 hour is equal to 3,600 seconds. Now pay attention to how I place them. Why did I place this on top and why did I place this on the bottom? It's all like, the idea is we need to cancel the kilometer per hour. So 1,000 meter per 1 kilometer, you're gonna cancel kilometer and kilometer. 1 hour per 3,600 seconds, you're gonna cancel hour and hour. And what's gonna be left is 135 times 1,000 meters over 3,600 seconds, and you're gonna get 37.5 meter per second. Alright, so we finished with this part. Now we need to change the 10 minutes into seconds, so you're just gonna multiply by 60, you're gonna get 600 seconds. And now to change it into meter per second squared, it's gonna be 37.6 meter per second over 600 seconds, so you put it on the calculator. And you are gonna get an answer of, I believe this is not 6, this is 5, sorry, that's my mistake. So 37.5 over 600, you are gonna get an answer of 0.0625. So this is our answer in meter per second squared. Alright, so this is the answer for question number 6. We don't have 7, 8, 9, 10, 11, 12, 13, 14, 15. We move on to question number 16. The scatter plot below shows the number of hours a group of students spent studying and the corresponding grade point average. The line of best fit is also drawn. What type of correlation is shown in the scatter diagram above? This is very obvious. It's a positive. It's a linear positive. Okay, we move on to part B. They want us to find the equation of the line of best fit. The equation of any line is y is equal to ax plus b. So let us find the slope by taking 2 points. Let us say this line, this point, sorry, and so this point and this point over here. This point is 2, 2, and this, not 2, 2. Yeah, it is 2, 2, sorry, my bad. And this point over here is 4, 3. Now to find the slope, okay, we find the slope, so it becomes 3 minus 2 over 4 minus 2. So it becomes 1 over 2, which is then 0.5. So we have the value of a, which is 0.5. So y is equal to 0.5x plus b. Now to find the value of b, you're going to take any point, for example 2, and you're going to substitute it. So it becomes 2 is equal to 0.5 times 2 plus b. So 2 is equal to 1 plus b. The value of b is equal to 1. So the line of best fit is equal to y is equal to 0.5x plus 1. We move on to part C. They said in part C, find a good estimate for the grade point average of a student that studied for 4 hours. For 4 hours, their grade point average is going to be 3. That's it for number 16. We move on to number 33. Going down, down, down. I think I missed it. Wait. Here. 33. It is the last question. Okay. So in question number 33, we have part A. The scatter plot below shows the number of lessons a group of students missed during a year and the corresponding grade point average. Okay, they said what type of correlation is shown in the scatter diagram. It's definitely a strong negative correlation. So over here it is strong negative linear. Okay? Now on the scatter diagram, they want us to draw the line of best fit. Of course, you have to bring a ruler with you and you draw the proper line of best fit. Find a good estimate for the grade point average of a student who missed 40 lessons. A student who misses 40 lessons have an approximate, in my opinion, I got 15. Maybe someone else will get something different or whatever, but it all depends on your graph. However you drew it, because in the answer key it is 10, in my opinion it is 15. So of course you're gonna be using a ruler to make it more accurate and whatever, but it's like to each person they get a different answer. Okay, now we did this, now we move on to part B. A teacher recorded the number of her 20 students who got grades between A and D on a math exam. The frequency table below shows the results. They want us to calculate the mode and the median. To calculate the mode, first of all, to find the mode, it means the most occurring thing, so it has to be the thing with the highest frequency. The thing with the highest frequency is B, so the mode grade is B, or the model grade is B. Moving on to the median. How do we find the median? We're gonna add everything, so it's gonna be 5 plus 7 plus 6 plus 2. We are gonna get 20. Okay, but because we're dealing with a table, we are gonna add 1, so 20 plus 1, it becomes 21. So we're gonna get 21. And now, what do we do with this 21? We're gonna find the cumulative frequency, so we're gonna keep on adding them. This is 5, then 12, then 18, and then 20. Okay, so we're gonna take this 21, and we are gonna divide it by 2. 21 divided by 2 is 10.5. Okay, so 10.5 can be found in this category over here. So B is our answer. So B is our median. So our model grade is B and the median grade is then B. Again, to find the mode, you just have to choose the one with the highest frequency. Of course, if there are no intervals. And to find the median, you're gonna add them all, then add 1 divided by to find the cumulative frequency and find into which sector it fits. So we move on to part C. In part C, it says the table below shows the average of all grade 8 students on a science test. So they said score in points is either between 0-30, between 30-50, 50-60, 60-70, 70-80, 80-90, whatever. And then the frequency is given over here. They said calculate an estimate for the mean score. I'm not gonna focus on the estimate right now. I'll just calculate how to find the mean score using the interval. So you're gonna find the mid-interval. What you're gonna do is you're gonna add these two together and divide them by 2 and you will get the mid-interval. So 0 plus 30 divided by 2, 15. 30 plus 50 divided by 2, 40. 50 plus 60 divided by 2, 55. 60 plus 70 divided by 2, 65. 70 plus 80 divided by 2, 75. And then 80 plus 90 divided by 2, 85. Now, this is the interval we're going to be using. We're going to multiply it by the frequency. So 15 times 15 plus 40 times 30 plus 55 times 50 plus 65 times 40 plus 75 times 10 plus 15 times 85. And then you're gonna divide it by the total frequency, which is 15 plus 30 plus 50 plus 40 plus 10 plus 15. So if we put it on the calculator, so we will get an answer of 55. On the calculator, it's exactly 55. So to calculate the mean score, not an estimate, just like mean score, it's gonna be 55. Draw a histogram. I don't think it's important, but I'm just gonna do it for the sake of, yani, in case it comes in the exam. So how they did it was they labeled 0, 1, 2, 3, 4, and 5. And then here they labeled 10, 20, 30, 40, 50, 60, 70, 80, and 90. And then they just like filled in the blocks. Of course, they found the frequency density. And how do you find the frequency density? You're supposed to take the width, okay? So you're gonna do, okay, this minus this, this minus this, this minus this, this minus this, all right? Now, of course, not all the widths are gonna be the same. The first one, the width is 30. The second one, the width is 20. The third one, fourth, fifth, and sixth, the widths are 10. So definitely they're gonna be different. And what you're gonna do is you're gonna take the frequency and divide them by the width. So for the first one, the frequency density is gonna be half, so it's gonna be like this. It's gonna be something like this, just like in general. For the second one, from 30 until 50, the frequency density is gonna be 1.5. Okay? For 50 until 60, it is gonna be 5. Okay, this is not accurate, it's just like a drawing. From 60 until 70, it's gonna be 4. From 70 until 80, it's gonna be 1. From 80 until 90, it is gonna be 1.5, so 1.5. And that's pretty much it for part 2. Thank you guys for watching. I hope you enjoyed. Have a wonderful day, and I hope you do well in your exam.